Question 11. Figure 4 shows a sketch of the graph with equation y is equal to the modulus of 2x minus 3k, where k is a positive constant. Part A, sketch the graph with equation y is equal to f of x, where f of x is k minus 2x minus 3k, modulus of. Stating the coordinates of the maximum point and the coordinates of any points where the graph cuts the coordinate axes for 4 marks. Well, if I've got a value of k and then I'm subtracting this graph above, I know that my maximum value will occur when I take 0 away from k. So at this point here, I'm going to get my maximum value, and on my original graph here, when y is equal to 0, this x value must be 3k over 2, because 2 lots of 3k over 2 minus 3k is 0. So immediately from looking at this equation, I can see that my maximum coordinate is going to be 3 over 2k, k. So let's sketch some axes. Let's first consider where it's going to cross the y-axis. So that's when x is equal to 0. So if x is equal to 0 here, then f of x is k minus 3k. So it will cross the axis here at minus 2k. I need to consider where it's going to cross the x-axis. So that's when f of x is equal to 0. Now there are two cases to consider here. The first is if 0 is equal to k minus the positive value of this modulus, which is going to be then minus 2x minus minus, so plus 3k. Adding 2x to both sides here and then dividing by 2 gives me x is equal to 2k. But I also have the negative value of this modulus, which would be 0 equal to k plus 2x minus 3k. And equating x here gives me a value of k. And so my line will cut k and 2k on the x-axis. As said earlier, my maximum point will be 3 over 2k, k. And so I can see I've got my inverted V shape crossing through k and 2k, minus 2k on the y-axis with the maximum point of 3k over 2k. Part B, find in terms of k the set of values of x for which k minus the modulus of 2x minus 3k is greater than x minus k, giving your answer in set notation. So again, I have two different cases to consider here for part B. I have the positive value of this modulus, which is k minus 2x plus 3k is greater than x minus k, and I have the negative value of this, which is k plus 2x minus 3k is greater than x minus k. So if we look at the left-hand side first of all, simplifying the left-hand side here, that's 4k minus 2x is greater than x minus k, and then adding 2x to both sides and adding k to both sides gives me 5k greater than 3x. Dividing through by 3 gives me x is less than 5 over 3k. Now looking at the other possible set of solutions, simplifying the left-hand side, that gives me 2x minus 2k is greater than x minus k. Now adding 2k and subtracting x gives me x is greater than k. And so my two solutions, or my two sets of solutions, are when x is greater than k and x is less than 5 over 3k. And so in set notation, I've got x with x less than 3 over 5k and x when x is greater than k. Find in terms of k the coordinates of the minimum point of the graph with equation y is equal to 3 minus 5 f half x. We have our maximum value for f of x. We know our maximum value from part A was 3 over 2k, k. So from A, we know the maximum value. And so the minimum point of this graph here will be when we subtract the maximum value. And so we've got half x going into this function. We know the x value to be 3 over 2k. So we've got half x is equal to 3 over 2k, which means my x value, multiplying both sides by 2, is going to be 3k. I know the maximum value to be k, so y will just be equal to 3 minus 5k. And so the coordinates of my minimum point will be 3k for x, 3 minus 5k for y, and that will be the minimum point on my graph with this equation.